Right. Chapter 2.2, our target is I can solve inequalities formed by conjunctions and disjunctions. Right, so a conjunction has and, which means that both sides must be true at all times. A disjunction has the word or, which means at least one side must be true. Okay, so example. Number 1, graph the solution set of the conjunction x is greater than or equal to -1 and x is greater than 2. Okay, so if I look at the number line for this one, here's my 0, here's -1, here's -2, here's 1. So this says x is greater than or equal, so that means that -1 is included, so we put a solid circle, and all the numbers greater are on that side. So that's a picture of that solution. Then if I look at this one, here's 0, here's 1, here's 2, here's 3, here's 4. X is greater than 2 would be an open circle here and an arrow going this way. Now this is an and statement, so the solution is only where both of them are true. While both of them are true, right in here, that's where they're both true, because from here over it's true for the yellow, from here over it's true for the green, so that means they're both true. So my solution set is all x such that, and this represents, it's from 2 greater, so x greater than 2. Now I will say that this is one of the unusual conjunctions. It's not how conjunctions usually look, but these can happen. Okay, and so a picture of the solution would be an open circle on 2 and an arrow going that way. That would be the graph picture. Number 2, graph the solution set of the conjunction x greater than or equal to -6 and x less than -2. Okay, now another way that this one might be written, and it means exactly the same thing, x greater than or equal to -6 and x less than -2. That's a very common way for a conjunction to be written. Okay, well, this one says greater than or equal to -6 right? So that would be an open, well actually it'd be a closed circle because it's greater than or equal, and an arrow going this way. This one says x less than -2. So again, if I did a separate number line for that one, okay, x less than negative 2 would be an open circle here and an arrow going this way. Well, where are they both true all the time? Well, they're both true all the time from here to here. So it's all of this in here because that's where we see both colors. So x has to be between negative 6 and negative 2. It's going to be greater than or equal to negative 6 and less than negative 2. So our solution is all x such that x is greater than or equal to negative 6 and x is less than negative 2. That's our solution. The actual picture, this is negative 6, this is 2. We would have a closed circle on 6, an open circle, I'm sorry, that should be a negative 2, open circle here, and then the picture would be everything in between those two, and including the negative 6, but not including the 2. Right, example 3. Example 3, we have graph the solution set of the disjunction x is less than 1 or x is greater than 4. Okay, so again, if we look at it individually, here's 0, 1, 2, 3, 4. If I graph this one, so open circle on 1, and x greater is going that way. If I graph the second one, oops, I'm sorry, I made a mistake. Let's go back. It says x is less than 1. So it should go that way. Okay? Then if I do the second one, this says x is greater than 4. So it's an open circle this way and an arrow going this way. Now the key here is that this is an or statement. So if I pick something from here, this side will always be true. Okay? If I pick something from here, this side will always be true. So at least one side is always true, as long as I pick from those areas, those regions. So we would say all x such that x is less than 1 or x is greater than 4. Okay? And the picture would be open circle on 1, open circle on 4, and then the solution would be everything to the left of negative or positive 1 and everything to the right of positive 4. So that would be a picture of the solution. Now this is the most common way a graph will look when it's an or statement. Okay? All right, example 4. I have 3x minus 4 is greater than or equal to negative 1 and is less than 8. So this is another example of a conjunction, because when I read it, I have to say and, because we always read from where the variable is. So this is greater than this, and this is less than this. So we have both situations. Okay, now this is a conjunction, and we can actually solve it exactly the way it is. And what we do is we notice that there are actually three regions. There's this one where the x is, there's this side, the left side, and the right side. So we start in the middle because we want to get x by itself. And as long as whatever we do to the middle, we do to both outsides, we will get true statements. Now, the next thing would be to divide by 3. So I get 1 here, here I get x, and here I get 4. Okay? So this tells me that x has to be between 1 and 4. So our solution set, well, let's draw the graph first. So here's 0, 1, 2, 3, 4, 5, and -1, -2, right? So this says x greater than or equal to 1, so that's a closed circle here. And greater than means I'm going to go this direction. Then this says x less than 4, so that's going to be an open circle on 4, and x has to be less than, so I'm going this direction. Now notice that this is where they're both true all the time, so that's our solution. So our solution is x such that x is greater than or equal to 1, because x has to be between or equal to 1, but less than 4. Okay, and the graph we would have a closed circle on 1, an open circle on 4, and then everything in between would make both sides true every time. Okay? Example 5. Solve 5 plus 3x is less than or equal to 2, or 2x minus 2 is greater than 4 minus x. The or tells us it's a disjunction, so I solve each side separately. So I get x is less than or equal to -1. I didn't have to divide by a negative, so I don't flip. This should be an x. So I'm going to add x. So I get 3x minus 2 is greater than 4. Add 2. 3x is greater than 6. Divide by 3. I get x is greater than 2. Okay, so this says x less than or equal to -1. Gives me that. This says x greater than 2, so open circle here and an arrow going this way. Because it's an or, then the answer is just what the graph says. So it's all x such that x is less than or equal to -1, or x is greater than 2. So this would be our solution.